Hey guys, welcome back. We are doing our example now where we're trying to express the triple integral of f of xyz of dv in 6 ways where the region E is the solid bounded by these 3 planes. So we have the z equals 0 plane, which is this blue plane that you see right here. We have y equals z, which is this burgundy red plane that you see right here. And then we have the planes that x is equal to the positive square root of 1 minus y, and then x equals the negative square root of 1 minus y, which is our green and our purple planes. So in order for us to set up 6 different integrals to get this region, which you guys will see here, we have circled it right here. It's this little region right here. What we need to do first is we want to draw traces. We want to draw the traces of each of our planes. So what is going on in the xy plane, what is going on in the yz plane, and what's going on in the xz plane. So you want to be able to get that because that's going to be our 2 outer integrals when we set these things up. So the first thing we're going to do is we're going to find equations that relates to both x and y. And we're giving them up there. So we're given that x squared is equal to 1 minus y, which means that x is equal to the positive and the negative square root of 1 minus y. But we're also given that y is equal to 1 minus x squared. And we're going to use this equation to actually graph our trace, because we know what that looks like, right? We know that it's a parabola facing down that has a y-intercept at 1, and it's going to cross the x-axis at positive 1 and also at negative 1. And so here's our region that we have. And so what we've actually done is we've actually calculated, we've looked at this bottom piece right there, right? So that's what this graph looks like. The next thing we're going to do is we're going to look at y and z, right? So we're pretty much given that z is equal to y and that y is equal to z. So we can go ahead and graph the line y equals z. And so we need a little bit of a bounding here, right? So one thing we want to do is we want to remember that we're looking at the plane of yz. Well, x is actually 0 on that plane, right? Because we're looking at this plane right here. So if we set x equal to 0, we can see that we're also going to be bounded by the fact that y is equal to 1. So we're going to go ahead and do this. All right. And then the last thing that we're going to do to set this problem up is we're going to say, all right, well, what's our relationship between, oh, and by the way, just really quickly, that's actually this region right here, right? These little regions that you see right there. All right. And then the last part of the problem is, well, let's go on to the xz plane. Well, this is pretty straightforward because we actually already have an equation where if y is equal to z, we can rewrite or substitute in that x is equal to the positive and negative square root of 1 minus z. And we get that z is equal to 1 minus x squared. So this looks exactly like our first picture, where again we have a parabola facing down, like so, and we have our region right here. All right, so these are our traces. This is the traces that we're going to use in order to solve this problem. So that's actually a very first step. And by the way, this picture here, this is actually, should have chosen a different color. I'm seeing the screen's not great, but it's actually this region, or actually, let me just really quickly, let's do some peek. It's actually this region right there. There's our little region that we found right there. All right, so it's kind of the top part of the burgundy is right here. This is the circle that goes on the blue, and then this is actually the actual curve that's going up from the blue to the burgundy and vice versa. So this is where we're looking at our traces. So I'm going to pause the video and I'm going to put equations out for us so we can actually start setting stuff up. All right, so yeah, be right back.